So welcome to this. This is the Further Math Support Programme online revision session for OCR Statistics 2. And what we're going to look at today is aspects of something called the normal distribution. Now this is quite critical in most areas of statistics. It's one of the fundamental distributions that we use. So as a consequence, you need to make sure that you have a very good understanding of its use, also when we can use it to model. Okay, that's quite important. But in terms of the examination, we need to be able to solve problems concerning the normal distribution. So the key things are we're given a mean, mu, and we're given a variance, sigma squared. And using these and the fact that it's normally distributed, we need to be able to find probabilities from the distribution, but also we need to be able to work backwards and estimate your parameters mu and sigma from experimental probability, or known probabilities as well. And that's not so bad, that's quite pleasant actually. Also, we need to be able to, occasionally, where required, use the normal distribution as a Poisson approximation or as a binomial approximation, okay, depending on which distribution we're using. But you also need to know when we can do these. So with the Poisson, if you get a parameter mu that is greater than 15, clearly you can't use the tables anymore to do these. So the normal distribution will become appropriate. For the binomial, now n has to be large, p has to be small, but generally speaking, these two conditions also have to be true. Okay, so the expectation has to be greater than 5, as does n times q as well. So this sort of guarantees the fact that we need to be dealing with large n. So in this question, we have a random variable y, and it's got a normal distribution with mu and sigma squared. And we're also told that we've got some probabilities. The probability that y is less than 48.0 is the same as the probability that y is greater than 57.0, and we're stated that both of these probabilities are 0.0668. And we've got to find the value y0 such that the probability of exceeding y0 is equal to 0.05. So with this question, the first thing that we have to do is to actually work out what my parameters mu and sigma squared are. Without those, there's not a lot I can do. So it's a good idea to just split these up first of all. So I know that the probability of y being less than 48.0 is equal to 0.0668, and I also know that the probability of y being less than 57.0 is equal to 0.9332. Okay, because what we can do with this, I'll just show you with a picture. We're trying to find the mean that we don't know. We've got a normal distribution. There's 57. And that area there is 0.0668. So as a consequence, the rest of the area is 1 minus. Other key things to bear in mind. Here's 48. It's not the greatest drawing, but this is also and 0.0668. So we have some ideas of symmetry here. Okay, so we know as a consequence that the mean must be exactly halfway between the two. Okay, that's something that's quite useful to bear in mind. So we can use that, because of the symmetry, we can use that to our advantage. So I know that the mean in this situation is exactly that. It's going to be halfway between the two. Okay, there are other ways, and I'll show you when we find sigma how we use the normal distribution to do this. Okay, so I know that the mean is 52.5, so you're picking up 2 marks for doing that aspect there. Okay, now to work out sigma, I'm going to use this statement here. Okay, you should know that your normal distribution table only has probabilities that are greater than a half, so therefore I have to use this one here. Okay, so if I go to the normal distribution table, okay, I'm looking up a value of 0.9332, and you just have to go hunting. Okay, so 9332, if you look long and hard, is this value here. Okay, so what that tells me is that a probability of 0.9332 corresponds to a z value of 1.5. Okay, so let's just reiterate that. We've got the probability that y being less than or equal to 57.0 gives me a probability of 0.9332. That corresponds to a z value of 1.50. So you'll see some notations where it says the inverse normal distribution of 0.9332 is equal to 1.50. So that's fine. Well, z is the standardized distribution, so z is actually equal to x minus mu over sigma. And this equation here is the one that's going to allow me to do this calculation further. So therefore 1.50 is going to be equal to x, which is 57 for this particular probability, minus the mean, which we've worked out to be 52.5, divided by sigma. So sigma is equal to 4.5 divided by 1.5, which is 3. Okay, so we've now worked out my sigma. You get a lot of marks for this. Okay, so in this particular case, we are going, well, 2. You're going to get B1 and A1 for these. Okay, what you could have done is set up 2 statements and solve them simultaneously. So if you had set up, I'll just do it in this corner here, you could have set up the fact that 1.5 is equal to 57 minus mu over sigma, and you could also set up the fact that minus 1.5, because of symmetry, is equal to 48 minus mu over sigma, and then by solving that simultaneously you would also have ended up with the same 2 values for mu and sigma. So that's a different way of doing this particular question, okay, which is quite nice. So now we can answer the question. We need to find the probability such that, value of y0 such that the probability of y exceeding that is 0.05. So what we need to do is recognize, again, I'm going to change color of this so you can see what we're doing. So I know that the probability of y being less than y0 is equal to 0.95. And if you look that up in a table, that corresponds to a z value of 1.645. And again, using the same mathematics, z is equal to x minus mu over sigma, except in this case we're not using x, we're going to use y0. Then we've got 1.645 is equal to y0 minus the mean, which we now know. Okay, the mean is now 52.5. It's always a good idea, once you know it, to actually rewrite your distribution. Okay, y0 minus 52.5 divided by 3, and if you solve that equation, you get y0 to equal 57.4. And again, we're always doing to 3 significant figures. So you get 3 marks for this. Okay, you get a method mark for standardizing. You then get an accuracy mark for using the correct numbers in there. Okay, and you get a B mark for getting your Z value correct. Okay, so my advice is learn this procedure. It's quite a difficult question, this one. Okay, so this covers a lot of aspects of what's going on with these probabilities. Okay, so another question we've got. In a large town, 35% of the inhabitants have access to TV channel C. A random sample of 60 is obtained, and we're asked to use a suitable approximation to find the probability that 18 or fewer inhabitants in the sample have access to channel C. Okay, so again, we're probably going to be required to use a normal distribution table here because we're asked to do an approximation of some type. So we need to think about what's really going on. So we're told that there is a proportion of inhabitants that have access to the TV, and we have a sample size. So really, we're dealing with the fact that X is a binomial distribution with 60 inhabitants, and a probability of having channel C is 0.35. Okay, so you can instantly realize that you don't have your sample size n is too large for you to be able to use the tables. So as a consequence, we are going to need to do an approximation. So let's just continue looking at the question first. So by using an approximation to find the probability that 18 or fewer have access. So if we put that into proper speak, we're going to have this. Now it's very important that you understand that the original distribution is discrete. Okay, so we can work out the mean. So the mean of a binomial is n times p. So if you work out the mean, you're going to get 21. and you can work out the variance, and the variance is NPQ, and if you work that out, we're going to get 13.65, and that's what sigma squared would equal. So as a consequence, what we can do is we can approximate this distribution. Okay, so x can be approximated as a normal distribution, 21 square root of 13.65 squared. I always like to write my normal distribution as something squared. Okay, that's really quite important. Now, what we have to realize is we are going from a discrete to a continuous distribution. So we need to do something called continuity corrections. And it's understanding that 18 now has a width. So 18 could, in theory, be any value up to 18.5. So we're actually looking now at this situation. Okay, so we need to use the normal distribution tables to do this, and we do this by standardizing. Okay, so z is equal to x minus mu on sigma, which in this case is going to be 18.5 minus 21, all divided by the square root of 13.65, and working that out is going to give me minus 0.6767. Okay, now we can't look up negative z values, so I'll show you how that works in a minute. So what we're going to do is we're going to look up z equals 0.6767, and I'll show you what to do with that in a minute. So to look that up, you're going to look up 0.67. Okay, so 0.6767. Now we can only really look up 3 decimals, so you need to realize that this is really 0.677. So we look up 0.67, which is this. So 0.67 is going to give me 0.7486, and then we look up an additional 7, and we put that at the end. So that's an additional 23, and we put that right at the end, and then we add these together. Okay, so that's going to give me 905, and that's still going to be a 7. Okay, now you could argue that it's sort of halfway between 19 and 23, so you should be looking at 21, but this is an acceptable answer as well. Okay, so just be very aware of that. Okay, so that's what your z value would be. So if z, I'm just going to the next page, if z is equal to 0.677, then the probability of that is equal to 0.7509, and all we do is, if instead your z value is negative, we look at the complement probability, so that's 0.2491. Okay, and that's your answer to this particular question, which is quite nice. So first of all, the way it's marked is anything that rounds to 0.249 is quite good, so therefore you could have used the midpoint quite happily. But let me show you where all your marks are now allocated. So with this question, okay, you're going to get 1 mark for stating the fact that we're dealing with a binomial distribution. You're going to get 1 mark for doing the correct approximation to the normal distribution. Okay, you get an accuracy mark for getting your variance correct. Okay, you get another mark for standardizing, which you will lose if you don't do your continuity correction, which basically means your final 3 marks you can't get correct. Okay, you then get an accuracy mark for getting to this point, and then a final accuracy mark for getting the correct answer. So you can see, if you don't use continuity or you don't standardize, you are going to lose half of the marks on this question. So it's very important you're aware of that. Okay, so this is a typical approximation question, and it's a very similar idea if you were using the Poisson. Okay, so final question in this recording. We've got the number of customers' complaints received by a company per day can be denoted as a Poisson distribution. So we're given that x is Poisson 2.2. Okay. In a week of 5 working days, the probability that there are at least n customer complaints is 0.146, correct to 3 significant figures, and we're asked to use the tables to find the value of n. So first of all, you actually need to realize that my distribution y, because we do need to start thinking about this, is actually Poisson 11, and that's because we're dealing with 5 working days, and this is only per day. Okay, so we want to work out the probability that there are at least n customer complaints is 0.146. So the probability that y exceeds a particular value is equal to 0.146. Okay, so what we need to think about doing is turning this round. So the probability that y is less than and equal to n minus 1, don't forget this is discrete, is equal to 0.854. Okay, and if you look at that, that wonderfully lives here. Okay, so the probability that y is less than or equal to 14 is equal to 0.854. So as a consequence, n minus 1 is 14, so n is equal to 15. Okay, and you've got to be very, very, very careful to make sure that those steps are followed in that way. This is where a lot of students go wrong. When they switch their probabilities around, they fail to choose n minus 1. Okay, so you get 3 marks for this. You get a method mark for stating that you're dealing with Poisson 11. You get another method mark for getting effectively this situation out here, and then your accuracy mark is for working out that n is equal to 15. So then we're asked here to use a suitable approximation to find the probability that in a period of 20 working days there are fewer than 38 complaints. Okay, so it's always a good idea just to think about the setup of this. So my distribution, again, y, is going to be Poisson, and in this case 44. Okay, because I'm going to have 2.2 multiplied by 20. Excuse me. Now we can see here that mu is greater than 15, so it makes sense to do the approximation. And don't forget, the mean for this Poisson is 44, as is the variance. So I'm going to be using the fact that y can be approximated as a normal distribution, 44 root 44 squared. And again, as before, I'm a great believer in writing this as something squared, sigma squared. Okay, so again, the question is asking for us to find the probability that there are fewer than 38 customer complaints. So again, what we need to be able to do here is approximate it correctly. So let me change the ink color again so you can see the approximation. So what we're going to do again is this idea of a continuity, because we're going from a discrete to a continuous. So in this particular case, y is strictly less than 38. So we need to realize that when we do this, that y is going to be less than or equal to 37.5. Okay, and that's really, really important that we understand how this continuity works. Okay, so again, standardizing this, we're going to have z is equal to x, or y in this case, 37.5 minus 44 over root 44, which as before is going to give me a z value of minus 0.980. So going to my table again, we look up 980, so this is just a segment of it, but if we do that, we are going to get a value of excuse me, sorry. So let's just write the z values down again, so I've got it. So z is 0.980, which actually corresponds to this one. Okay, this was your 8s, this is your 0.9s. Okay, so the probability of this is 0.8340. So again, if I wanted a negative z value, so minus 0.980, then my probability would be the complement, so 1660. Okay, just by taking the complement. And that's that. So that's quite nice. So let me show you how your marks are awarded for this question. Okay, same sort of idea. You're going to get 1 mark for recognizing the approximation in this particular case. Okay, you're going to get an accuracy mark for getting both the mean and the variance completely correct. Okay, you're then going to get a method mark for standardizing, which is good. And you're going to get, in this case, an of using continuity corrections correctly. You're then going to get your accuracy mark for getting the correct Z value, and then you only get 1 mark, okay, for working out the final answer here, okay, because it's regarded as not being that difficult in this particular case. So this is quite a big question. In total, it's worth 14 marks, but now a week of 5 working days in which at least, so that's the same question, a week of 5 working days in which at least n customer complaints are received, where n is the value found in part 1, so that was 15, is called a bad week. And we're asked to use a suitable approximation to find the probability that in 40 randomly chosen weeks, more than 7 are bad. So in this sort of situation, I'd be wanting to redeem my situation. So here, this is let B for bad be the number of weeks which are bad. Okay, now we worked out that there's a probability of being bad which is 0.146. Okay, so the probability, if we look back at this, the probability of being 15 or greater turned out to be, from the question, 0.146. So this distribution here, so let B, is going to be a binomial distribution where we are doing something 40 times, and the probability of having a bad week is going to be 0.146. Okay, and you get yourself a method mark for that, which is nice. Now, you can't use your tables for this, so again, it's all about approximating this to the normal. So if we do that, B can be approximated as a normal. You need to work out the mean, so that's NP. So in this case, NP is going to equal 5.84, and you also need to work out your variance, NPQ, which is going to give me 4.98736. So it can be approximated as a normal, 5.84 square root of 4.98736 squared. Okay, so you can, as I say, you get your method mark for setting it up correctly in the first place. You're going to get another method mark for approximating and an accuracy mark for getting both of your parameters correct. So you get quite a lot of marks for this, really. And what we want is we want to find the probability that more than 7 are bad. So B is greater than 7. Okay, now to do this, personally, I prefer to turn everything around. So this is 1 minus the probability that B is less than or equal to 6. When we apply continuity to this, oops, change the colour of my pen. When we apply continuity to this, so continuity correction, this is now going to be 1 minus the probability that B is less than or equal to 6.5. Okay, and it's quite important that you apply that correctly. Sorry, that's 7, isn't it? So 7.5. Okay, so again, the same principles now hold as we did in the previous sorts of questions with these. So first step is to standardize. I'm going to use my table in a minute, but again, we're looking for 1 minus the probability that B is less than or equal to 7.5. Just to remind you of the normal distribution, so it's binomial, 5.84 square root of 4.98736 squared. So we need to standardize this. Okay, so I'm just going to look at this aspect, but I'm going to make sure I don't forget the 1 minus. Okay, so Z is equal to X minus mu over sigma, 4.98736, and that's going to give me a Z value of 0.7433. Okay, so the 3 we don't need to worry about too much. So we're going to deal with 0.7, 0.74. So 0.74 will give me a probability of 0.7704, and then I need the additional 3, which means I'm going to add 9 to the final digit, which is going to give me 0.7713. So that's this value here, 0.7713. So therefore the probability that I'm looking for, which is the probability of being greater than 7, if you go back to your original distribution, is going to be 1 minus 0.7713, which is going to give me a value of 0.2287. And again, you do get some tolerance for the answer of this. So anything that rounds to 228 or between 228 and 229 will be acceptable. Okay, so your marks in total for this question, okay, just so you can see, we've talked about your first 3 marks, so your final 3 marks come from the following. You get a method mark for standardizing correctly. Okay, you're then going to get an accuracy mark if effectively you got the correct Z value, but it comes down to doing the correct continuity. Okay, so if we don't see the correct continuity, you certainly don't get your accuracy mark. Okay, but this won't be correct either, would it? So, and then you get your final accuracy mark for doing that as well. Okay, so just be aware of that. So these are nice questions. You don't need to worry too much, but you do need to be very aware of when you're using the continuity corrections. You need to be able to use it correctly.